Now for cubic functions, all of that is identical except for the shape. The shape of a cubic function is going to be, let me get my colors going here. The shape of a cubic function is going to look something like that. So it kind of looks like a radical function doubled up and flipped. All right? So it's a little s. And so we just got to keep that in mind. But otherwise, it's exactly the same process. We have y equals a cubed root of x minus h plus k. So we list our a as 3, positive 3 this time, so nothing flips. Our h, it tells us that x plus 2 is under the radical, so we have h equals negative 2, and then k equals negative 1. So we're going to be shifting this thing to the left 2 and down 1. All right? And again, I need to write this, my OG, without any shifts. So y equals 3 cube root of x. No shifts. The cube root centers at 0, 0, just like the square root starts at 0, 0, because again, if you plug in 0 for x, you get 0 for y. Then we go to where x equals 1, so I get y equals 3 cube root of 1, so y equals 3. Or you could think of it as like whatever a is, that's what y will be at x equals 1. So at 1, we're at 1 comma 3. Okay, and then the only other thing we haven't really looked at is the fact that we have to go into the negatives. So we also have to do y equals cube root, or excuse me, let me erase that. Y equals negative, y equals 3 cube root of negative 1. Okay, so we get y equals negative 3. So then at negative 1, we're down at negative 3 here. So now we've got our normal smooth kind of radical shaped curve like a parabola turned sideways, and our other one, big S. So this is our OG. Our OG, original graph. And then again, I just need to shift this thing according to h and k. So we're going to move this dot 2 to the left and down 1. We're going to move this dot 2 to the left and down 1. We're going to move this dot 2 to the left and down 1. So let's change our pen thickness here and see if that helps. Maybe we'll go there. So we're going to go 2 to the left and down 1, 2 to the left, down 1, 2 to the left, down 1. Now we have all 3 of our dots. And I'm going to change my color here. We'll go back to our normal thickness and we'll draw a line. Okay. And there you go. Now you have your final graph. Your y equals 3 cube root of x plus 2 minus 1 in blue there. Okay. Now, looking at domain and range. Domain for cubic functions is actually pretty simple. Unless you see some sort of break in the action here, there's no break in our line, so it looks what we call continuous. So our domain for cubic functions is just all real. And if you look at it, it makes sense. I could put in this x value here, and I would get a point right there. I could put in this x value here, and I could get a point right there. I could put in 0, and I get a point. I could put in anything. And because we have arrows on the end, there's nothing saying, giving us any indication that there's any point in this that breaks. Any point that if I put in an x value, I would not get an answer out. Like if I put it into my calculator, I would get an error. There's nothing that's telling me that. So I've got all real numbers. Okay? Whereas my range is pretty similar. I don't see any value for y that couldn't exist. There's no what we call asymptotes, which we'll talk about in rational functions. There's none of that. So there's no break in the y value. Whereas before, we only could get up to y equaled 1. So again, all real for range. Okay, hope that helped. See you guys on Monday or Tuesday.